Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 78, for broadcast on the 30th of June 2023. Coming up on SpaceTime, an amino acid essential for life found in interstellar space, important upgrades to NASA's Deep Space Network, and rocket labs coming to a storm near you. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered tryptophan, one of the 20 amino acids considered essential for life as we know it in deep space. The detection, reported in the monthly notices of the Royal Astronomical Society, was found in data from NASA's Spitzer Space Telescope during observations of a nearby star-forming region. Amino acids are the building blocks of proteins, which are the key macromolecules for the development of life on Earth. The authors identified more than 10 emission bands for the molecule tryptophan inside the Perseus molecular cloud complex, and in particular inside the stellar system IC348, located 1,000 light-years away. This region is generally invisible to the unaided eye, but it shines brightly when viewed in infrared wavelengths. One of the study's authors, Susana Iglesias-Groth from the Canary Islands Institute of Astrophysics, says given the spectral coverage in the infrared and the large spectroscopic database from the Spitzer telescope, this amino acid was an obvious candidate to search for in space. IC348 is an exceptional star-forming region and an extraordinary chemical laboratory. And thanks to its proximity to the Earth, astronomers carry out some of the most intensive searches for molecules in this interstellar medium. Iglesias-Groth had also recently detected molecules such as water, carbon dioxide, hydrogen cyanide, acetylene, benzene, polycyclic aromatic hydrocarbons, and fullerenes in the same region. She says the novelty of this work is that tryptophan has never before been detected in interstellar space. And in spite of decades of research, there has never been a confirmed detection of other amino acids in any other star-forming region. Iglesias-Groth believes evidence for tryptophan-associated emission lines might also be found in other star-forming regions, as could other amino acids. In fact, they may be common in the gas from which stars and planets are formed. She says it's also likely amino acids are enriching the gas in protoplanetary disks and in the atmospheres of young newly formed exoplanets, perhaps accelerating the emergence of life. The analysis of the molecule's emission bands also allowed the authors to estimate the cloud's temperature in the region. They found it was around 280 Kelvin, that's 7 degrees Celsius, a temperature very similar to that already measured for molecular hydrogen and water in her previous studies. The new work also provides an estimate for the abundance of tryptophan in this region, finding it was around 10 billion times lower than for molecular hydrogen. Amino acids are often found inside meteorites on Earth, and so they may have been present as early as the formation of the solar system 4.6 billion years ago. Iglesias-Groth says this new discovery, and hopefully that of other amino acids in the near future, could indicate that protein-building agents, which are the key to the development of living organisms, exist naturally in the regions of space where stars and planetary systems are formed. And that suggests that life may also be more common in our galaxy than what we could have predicted. This is SpaceTime. Still to come, major upgrades to NASA's Deep Space Communications Network, and Rocket Lab coming to a storm near you. All that and more still to come on SpaceTime. NASA is in the process of upgrading its deep space communications network. The upgrade's necessary in order to communicate with more spacecraft than ever before and to accommodate evolving mission needs. Managed by the Jet Propulsion Laboratory in Pasadena, California, the Deep Space Network is what enables missions to track, send commands to, and receive scientific data from faraway spacecraft. For example, when NASA's Mars Perseverance rover touched down on the Red Planet, it was the agency's Deep Space Network which provided direct communications with the rover, enabling the mission to send and receive data that helped make the event possible. And when OSIRIS-REx took samples from the asteroid Bennu, it was the Deep Space Network which played a crucial role not just in sending the command sequence to the probe, but also for transmitting its stunning images back to Earth. In fact, the Deep Space Communications Network has been the backbone of NASA's communications system since 1963. It's currently supporting more than 39 missions, with 30 more missions now in development. And with that sort of a workload, NASA needs to upgrade its capacity. The Deep Space Network consists of tracking antennas across 3 complexes evenly spaced around the planet. There's the Goldstone complex near Barstow, California, there's one in Madrid, Spain, and then there's the Tidbinbilla Deep Space Network near the Australian capital of Canberra. In addition to supporting missions, the antennas are regularly used to conduct radio science, studying planets, black holes, and tracking near-Earth objects. As part of this upgrade, NASA's constructed 2 new antenna dishes, increasing capacity from 12 to 14. In January 2021, the Deep Space Network commissioned its new 34-metre dish named DSS-56 at its Madrid complex. While previous antennas were limited in the frequency bands they could receive or transmit, and that often restricted them to communicating with specific spacecraft, the new Madrid dish is an all-in-one antenna, able to send and receive the full range of communications frequencies used by NASA. Soon after bringing DSS-56 online, NASA completed 11 months of critical upgrades to DSS-43. That's the massive 70-metre dish at Tidbinbilla. And it was a crucial upgrade because DSS-43 is the only dish in the Southern Hemisphere with a transmitter powerful enough to broadcast at the right frequency to send commands to the distant Voyager 2 spacecraft, which is now hurtling through interstellar space and is the most distant man-made object in history. In fact, the DSS-43 refurbishment has paved the way for similar upgrades to the 70-metre dishes at Goldstone and Madrid. The improvements are all part of a project to meet not just the heightened demand, but also the evolving mission needs of NASA. Missions increasingly generate far more data now than what they did in the past. In fact, the data rate from deep space spacecraft has grown by more than 10 times since the first lunar missions in the 1960s. And as NASA looks towards sending humans to Mars, the need for higher data volumes will only increase further. And optical communications is one tool that can help meet this demand for higher data volumes, using lasers to enable higher bandwidth communications. Experiments doing this are now being carried out. Meanwhile, the Deep Space Network's radio antennas remain the backbone of its operations. This report from NASA TV.
NASA has robotic explorers all over our solar system and beyond. But how do we communicate with these faraway spacecraft? We communicate with them by using the big antennas of the Deep Space Network, or DSN. The DSN has 3 antenna complexes evenly spaced around the world in the United States, Spain, and Australia. That means that as the world turns, at least one antenna complex can always contact spacecraft no matter where they are in the sky above Earth. This antenna was constructed in 1965, a massive 70-meter dish, which has a total area of approximately 1 acre. This large antenna includes not only the 70-meter dish, but also a base that can turn to point it at any place in the sky. And along with the DSN antennas across the world, has helped us communicate with rovers landing on Mars, the New Horizons mission to Pluto, the Voyager missions to Jupiter, Saturn, and beyond, and more. The Deep Space Network provides the crucial connection for commanding spacecraft and receiving never-before-seen images and scientific information. The 70-meter antennas are driven by hydraulic drive systems using a 200-horsepower motor. That's the power of a car engine. The 70-meter antennas can communicate in S-band and X-band radio signals, which are two different types of radio communications used for talking with far-away spacecraft.
This is Space Time. Still to come, Rocket Lab launches the second of its two dedicated missions for NASA, deploying a constellation of tropical cyclone monitoring satellites. And later in the science report, new studies warn that September Arctic sea ice could be gone by the 2030s. All that and more still to come on Space Time.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Rocket Lab has successfully launched the second of two dedicated missions for NASA to deploy a constellation of tropical cyclone monitoring satellites. The Electron Coming to a Storm Near You mission lifted off from Launch Complex 1 Pad B on New Zealand's Mahia Peninsula, deploying the two final CubeSats of NASA's Tropics constellation. The first pair of satellites were launched back on May 8th.
Stage 1, Stage 2, press for flight.
High purge flow, engine purge enabled. Deluge activated.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
And that is a beautiful liftoff for Electron. The final two tropic satellites are on their way and coming to a storm near you. With Electron now having cleared the pad, the next milestone is max Q. This is the point where the forces on Electron are at their greatest.
Clear max Q.
And there we have it. Electron has passed through max Q and continues on the way to space. Right now, Electron is traveling at over 2,000 kilometers per hour and is at an altitude of 20 kilometers.
Now, coming up next is main engine cutoff, or MECO, where the 9 Rutherford engines on Electron's first stage shut down to make way for separation between the first and second stages. Within seconds, the single space-optimized Rutherford engine on the second stage will ignite to carry the kick stage and the tropic satellites all the way to orbit. That should take place shortly at around T plus 2.5 minutes.
Stage 1 propulsion still nominal. Please stand by for MECO in roughly 30 seconds.
15 seconds to MECO.
AOS at Chatham Station.
Entered burnout detect mode.
And MECO confirmed.
Stage separation successful.
Stage ignition.
And just like clockwork, we have had MECO, Stage 1 and Stage 2 separation, and ignition of Electron's second stage. Coming up very shortly, we'll also see Electron's fairings separate and fall away. These two carbon composite halves form a protective nose cone over the tropic satellites, keeping them safe during ascent. Once we're in space, though, they're not needed as the forces on Electron are not nearly as great, so we can get rid of them and clear the way for payload separation. Now, for this mission, because we're headed to that 550-kilometre circular orbit straight away with Stage 2, we're leaving the fairing attached just a little bit longer than usual.
Fairing separation successful.
And that's fairing separation confirmed. We are at 4 minutes into flight now, and coming up next is a process unique to Electron, battery hot swap.
The pumps on Electron's Rutherford engines are powered by electron pumps, which draw their energy from batteries. Once we deplete the batteries, they are dead weight that we don't want to carry all the way to orbit, so we eject the batteries and swap over to a fresh set in flight.
So far, a nominal mission for Coming to a Storm Near You, the second of 2 dedicated launches to deploy a storm monitoring constellation for NASA.
Stage 2 propulsion still holding nominal.
Guidance is nominal, 200 seconds remaining.
Now we're coming up on that all-important battery hot swap. Powering engines with batteries is one of the things that makes the Rutherford engine special. The single Stage 2 engine requires a longer duration than the Stage 1 engines, so we have to hot swap the spent batteries to a third fresh one. This is one of the final gates to orbit, so let's listen into the operators in mission control for that call.
Nominal, approaching hot swap. Throttling down. Hot swap 664.
And there you have it, a
Propulsion is
clean
coming on.
hot swap for the second
That
stage
engine is
Rutherford engine. Electron continues to orbit with around 2 minutes remaining in today's Stage 2 burn.
Speed is good, altitude is good, Electron is good, T plus 7 minutes into the second Tropics mission for NASA. These two CubeSats, along with the two that we launched just 18 days ago, will provide members of the meteorological community with hourly returns over the same storm to more accurately predict patterns, which could save the lives and livelihoods of millions of people.
T plus 8 minutes in, and we are now around 30 kilometres away from that 550 kilometre target orbit. This Stage 2 burn is taking us all the way to a circular orbit. Then we have that dogleg inclination change just over the equator to put us in the correct plane for payload deployment coming up at 33 minutes into the mission. Electron is continuing well at speeds of over 19,000 kilometres per hour, ahead of SECO and kick stage separation.
SECO stands for second engine cutoff. Immediately after that shutdown, Electron's kick stage separates from the second stage, and in around 1 minute, the Curie engine will ignite and begin that plane change maneuver ahead of payload deployment.
SECO confirm.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
And that is SECO confirmed as planned. The kick stage has also cleanly separated, ready for that final Curie burn in around 20 minutes from now, followed by payload deployment at T plus 33 minutes.
The timing was key for the mission in order to get the 4-satellite constellation in the correct position, with deployment into their operational orbit within a 60-day period, with the two dedicated launches needing to take place within 18 days of each other. The spacecraft are all now in a 550-kilometre high orbit at an inclination of around 30 degrees. They're designed to collect tropical storm data more frequently than other weather satellites, allowing meteorologists and weather forecasters to improve their understanding of what a storm's doing. But to reach the low 30-degree inclination, Electron's second stage placed the kick stage and the tropic satellites into a circular orbit, and the kick stage then needed to carry out a plane change maneuver in order to position the satellites at 30 degrees.
Here's a question. How does a group of satellites, each no more than a foot long, help improve forecasts for tropical storms and hurricanes? Let's take a look. Hurricanes are some of the most powerful and destructive weather events on Earth. The 2020 Atlantic hurricane season was brutal, producing a record-breaking 30 named storms. What's more, 10 of those storms were characterized as rapidly intensifying, some throttling up by 100 miles per hour in under 2 days. Many weather satellites will generally measure a storm only once every few hours, leaving gaps in coverage where a storm may quickly strengthen. To help fill this observation gap, NASA is launching Tropics, a collection of satellites designed to make a big impact on our understanding of damaging storms. Their mission? To provide near-hourly observations of a storm's precipitation, temperature, and humidity, allowing scientists to better understand what drives a storm's intensification. To achieve this, researchers at MIT's Lincoln Laboratory developed a miniaturized microwave radiometer that's about the size of a cup of coffee. This small instrument will measure storm strength by detecting the thermal radiation naturally emitted by the oxygen and water vapor in the air. As Earth's climate continues to change, cost-effective but powerful satellites like Tropics will be an important tool to help us better observe developments driving rapid changes in powerful storms, and help forecasters better predict and prepare for the weather ahead.
The two Tropics launches mark Rocket Lab's 36th and 37th Electron missions. They also mark the company's 4th and 5th missions this year, bringing the total number of satellites launched by Electron to 163. And it doesn't end there. The launch was followed by the successful test flight of a modified version of the Electron called the HASTE, which stands for Hypersonic Accelerator Suborbital Test Electron. It's designed to carry heavier payloads up to 700 kilograms on suborbital sounding rocket missions. To do this, it uses a modified kick stage for hypersonic payload deployment and has options for different tailored fairings in order to accommodate larger payloads, including air-breathing, ballistic re-entry, boost-guided and space-based equipment. The inaugural launch of the Hasty took place from Rocket Lab's Launch Complex 2 in NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast, carrying a classified payload. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that the sea ice that usually forms around the Arctic during September could be completely melted by as soon as the 2030s. The findings, reported in the journal Nature Communications, are based on detailed studies by Korean, Canadian and German researchers who modelled the future of the Northern Pole under current and low emission scenarios. The authors say this future puts the ice doomsday clock a full decade earlier than previously thought. A new study shows that people with cannabis use disorder are at a higher risk of being diagnosed with illnesses such as depression, as well as non-psychotic and psychotic bipolar disorder. The findings, reported in the Journal of the American Medical Association, are based on a study of over 6.5 million people in Denmark. The researchers looked at diagnosis data for cannabis use disorder against diagnoses of these psychiatric disorders. And they say the disorder was associated with a higher risk for all of them, especially psychotic bipolar disorder. The researchers say the risk of being diagnosed with depression or bipolar disorder was highest in the 6 months after cannabis use disorder diagnoses. Scientists at the Queensland Museum Network have described 3 new species of carnivorous sponges collected on the Great Barrier Reef. The sponges were collected at a depth of 1,850 metres by the Schmidt Ocean Institute's research vessel Falkar using an ROV. You can read the details of the discovery and a description of each species in the journal Zootaxia. Nobel Prize syndrome, or Nobelitis, is a phenomenon associated with scientists, including Nobel Prize-winning researchers, who endorse or perform study in pseudoscientific areas in their later years, usually, although not always, after having won the esteemed prize for some legitimate scientific achievement. What makes this syndrome so special is the fact that you'd normally think that of all people in the world, Nobel laureates would be the most resistant to pseudoscience and crackery. However, Tim Mendham from Australian Skeptics says it seems on the contrary, Nobel disease underscores the fact that humans simply aren't immune to falling for crank ideas, pseudoscientific dogma and woo.
There's a case of an American academic who was doing stuff on neurobiology and doing sort of reasonable stuff on depression and that sort of stuff and the impact of the brain. And then on these conditions, on the physical conditions, then he was moving into some slightly fringy areas. He started looking at the impact of someone's birth date on their brain structure and the function of the brain. So you wonder, basically astrology almost, looking at someone's birth date and comparing that with brain scans, now whether you see what you want to see. He got mixed up with a group called the Institute of Noetic Sciences, which has been around for a while, started by astronaut Edgar Mitchell to look into sort of paranormal areas. And this group has been looking at a lot of things, psychic and, influence of psychic powers. They definitely believe in telepathy and psychokinesis, which is moving stuff with your mind, astral projection, your body going outside your body, etc. Channeling, which is about calling up ancient spirits. So an academic moving into further and further, not that this guy is necessarily involved in those woo things, but it's certainly getting involved in some strange areas, is not that uncommon. Unfortunately, there's what we call the Nobel rot of a number of Nobel scientists who have moved into some very fringy areas, normally outside the areas for which they won a Nobel Prize. And you think because they won a Nobel Prize, they have a certain imprimatur given to what they're doing now, which is selling a vitamin or working in some particular sort of esoteric field. It happens a lot, and we've come across academics, senior academics, professors, and as we say, Nobel Prize winners who do this sort of stuff. And whether it's because they believe that they can do no wrong because they've had this great achievement, or whether because they're just looking for something different, or whether they've just gone off the deep end.
It's amazing how common Nobel Prize syndrome can be, but...
Yeah, it happens a lot. Well, not to all of us, that'd be a bit unkind, but I mean, it happens enough to be noticed.
It never happened to you or me, for example.
Oh, never, no. But I know of skeptics, people who have been firm skeptics who have just suddenly turned and gone down a rabbit hole. Very sad to see when someone is obviously someone who applies strong critical thinking techniques then doesn't, to something which means something more to them. It's the old story. If you're balancing emotion and desire against sort of rationality, often rationality goes out the window, unfortunately. If it's something you really, really want, you're going to go down that path for a lot of people. Whether you're an academic or whether you're an ordinary person on the street, you've really got to be careful of that and think about where you're going. So, and you'd hope senior academics and scientists and things would do that, but apparently they don't.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.